Okay, so an adder is a circuit that's really important in a computer. So the way a computer works to do anything is that we have memory that keeps stuff we want to mess with, and we have registers that keep data that we're working with right now, and we have an arithmetic logic unit that will let me add numbers in two registers. So that's really like the basic parts of your computer, and you have a CPU that decides like what instructions to do at what time. So what I need to be able to do is add two numbers. It's one of the most fundamental things that I have to do on my computer. Because I need to add things to get relative addresses, I need to add things to do multiplication. We have to do addition all the time. So it's the basic root of most of our computation. Okay, so it has to be done bit by bit. So one idea is I need to, the most basic adder will add two one-digit binary numbers. Okay, so let's make two one-digit binary numbers. So just like anything else, we will have a 4-row truth table for this. And we'll have a sum that is the output of this. So if I add 0 plus 0, what do I get? If I add 0 plus 1, what do I get? If I add 1 plus 1, what do I get? Okay, I'm gonna ask you guys to vote for 3 different numbers. How many people vote for 0? Okay, good. How many people vote for 1? Okay, how many people vote for 2? How many people vote for all of them? Okay, I vote for all of them because it depends on what you're asking, right? So it's not a very specific question, right? What is the output of the addition of 1 plus 1? Well, in base 10, the answer is 2. And in base anything other than 1, the answer is 2, right? Or base 2. Any base other than 2, the answer is 2. So if I have base 3, the answer is still 2. So 1 plus 1 is actually equal to 2, but it's in decimal, right? But our output's going to be in binary, so this is actually equal to 1, 0 in binary, right? So that's why this is correct, because the digit that is in the rightmost place in an addition is the 0, right? So actually that's what we put in this column, but we have to do what? We have to carry, and that's what this 1 is, so that's why this is a correct answer also. So everybody was right. It just depends on what question you were answering. Now, if you weren't answering the question that I gave that went with that number, then maybe you should go look at your packets some more. Okay, so we need a carry bit 2, which we maybe didn't realize when we started this problem. So there's actually 2 outputs for addition, even though we're only adding binary numbers that only have 2 choices each. So the carry, we didn't need it for anything but this last one. Now this looks weird because I would rather my output actually look like the correct order, right? So this is backwards. So it would be cool if I just rewrite S over here. And then I can ignore this one. And now this looks like the actual digits, the 2 digits of the sum. That's the output, right? So if I consider C as the next column over, so like if I added 1 and 1 in like the old standard format, and this is in binary, then we get that, and then this ends up being S, and that ends up being C. So we have S is the rightmost bit, and C is the carry. Now, making a circuit for this is easy. So the hard part of this problem is that most of you didn't know what an adder was. So then even after I told you that it's a circuit that gives me the output if I add 2 digits, you might not have known that we needed 2 outputs. Okay, so you're going to face problems like this, and you have to think through it and figure out what your assumptions are. And then make a truth table and figure out a circuit.